Here we go. Review with limits of infinity. We have touched on it. However, I did get a text from a former student. It was T. Lee, and she wanted to see how do you show work on some of these infinite limits, because my professor tells me I'm getting them way too fast, and I forgot how to show work on the hard, difficult ones. Okay, so real quick, the thing that you were exposed to before when we did this long ago were Bobo-Botnitz's ratio. And this is how she was able to get it so quickly. Okay? If I use Bobo-Botnitz's ratio, and I only use Bobo-Botnitz's ratio when I'm analyzing in behavior, okay? And infinite limits are analyzing the in behaviors. What's my answer here? Exponents are the same, right? Yeah. So it will be 3/2. Now, this is not what I want you to do on the test. Now I want you to show the work. So that's why I scaffolded it into here, because it's dealing with this material. I want you to show the work. Work's not that bad. The way you show the work on infinite limits is you find the biggest power of x in the denominator and divide everything by that. Just that. Not the coefficient, just that. So if you need to refer to this video later, you can. 3x minus 1 all over 2x plus 5. I'm going to choose this x that I highlighted, and everything is going to be divided by that. Okay? This is the work that you'll show. Before I apply the limit, what do we do?
Why did you divide by 11?
That's the process. That's your work justification. You're going to see why when we do the harder problems. Simplify. Simplify this, simplify that, so that I truly have 3 minus 1 over x over 2 plus 5 over x. Why? Because that's the work to prove what you're doing, and not just straight up use Bobo-Botnitz's ratio just like that. Because Bobo-Botnitz's ratio doesn't necessarily work all the time. If I now apply the limit, what do these two fractions converge to? 0. Right? 1 divided by a huge number is a very tiny number, a limit approaching 0. So my ultimate answer can be written here with proof in justification, and you can box that in if you want.
Is this going to be on the test?
This will be on the test.
And we have to do it like
And you have to do it this way. Okay? Now, whenever you're in discussing in class, yes, use Bobo if you want to in college, but I want you to know how to justify it. Now, real quick, the same work is going to be for B. The only difference is we're going to plug in a negative. If I plug in a negative here and a negative here, does that change your answer? No. No, not on this one. Okay? This is each ratio. It doesn't really change the answer. Let's do another example. Let's do C this time. Okay, so I'm going to take every entity, 3x squared minus 1, and I'm going to divide everything, James, by what? Yep, because it's the biggest power of x in the denominator. Okay, so here we go. X. Josh, what do I do here? Simplify. Simplify this becomes 3x minus 1 over x all over 2 plus 5 over x. Now I just simplified, I can plug in. It's like whenever I used to say long ago, you just canceled h. What is the next thing that you're going to do? You're going to plug in that 0. Harry, when I plug in infinity here and here, what do those fractions converge to? 0. So now plug in infinity here, Harry, and what is your ultimate answer? Infinity. Infinity. 3 times infinity divided by 2 is a positive infinity. Guys, remember, these went to 0, and this went to 0. Okay?
Wait, why did those go to
Because look, because the bottom was growing exponentially. So 1 divided by a huge number is a very small number, which is 0. And 0 doesn't have positive or negative, it's just 0. Okay? Alright, here we go. Next one is this one. Now, it's very similar to this previous one, but I'm going to put a negative infinity instead of a positive infinity, which would, does that change my answer? Yes, because of the fact of this guy. So those of you who are thinking bigger on top is none, That's a good reference whenever you're shortcutting it at the very beginning. If you see none, it might be a positive or a negative infinity, or a positive or a negative zero, a positive or negative concept of some sort. Okay? Let's finish it up with these last two. And I have about 4 minutes. I will do this. Okay, here we go. 3x over x squared minus 1 over x squared over 2x squared over x squared plus 5 over x squared. I took the biggest power of x on the bottom and I'm dividing it. Just like Josh said, I'm going to simplify everything. And then I'll plug in the infinity. Plugging in the infinity, this converges to, anyone? 0. So my ultimate answer is going to be what? 0. Because it will be 0 over 2, which is not undefined. It will be 0. If I put negative infinity, what's the answer? Still 0. Because this is still going to converge to 0, and 0 over 2 is still 0. Okay? The last ones, and these are the ones that were too fast for him, for his liking. He wanted the work. And if the bell beats me, no worries, I'll finish it up. I'll just pause it. Here we go. Ultimately, what I'm trying to do is use this limit. I know it's been a while, but I'm going to change this to 2x quantity squared, and I'm going to then take the square root. Why? Because I'm now going to make this one huge square root. Do you remember this?
Why did you square the 2x?
Because I'm trying to create this so that ultimately I can bring them underneath the same thing. Now the last thing that I will do is I will bring this limit rule in, and if you can remember why that's allowable, I'll give you 5 points right now.
Should you what?
Why is that allowable?
Because you're just rewriting the same answer because...
No. Why is the limit being able to be brought inside of the square root allowable? It's not a form of one. Nice guess.
Because the limits apply to the equation.
I know it's been a while, and I really don't expect you to remember, but if you do, that's awesome. One of your limit laws, guys, the last limit law that you had on that list when we did limits long ago is this. This is a composite function. It's the square root of something else. So this is a composite function, an f of g of x. It's like f of g of x. The g of x is the stuff on the inside. The f part is the stuff on the outside. You with me? Composite functions, compositions?
Yes.
I can bring this limit inside of the f if and only if f of x is a continuous function. Square root of x is a continuous function, so I can bring it in. That's why. Okay, so let's simplify from here. So 4x squared over x squared all over 9x squared over x squared plus 4 over x squared. Josh said that I have to simplify. So I get 4 over 9 plus 4 over x squared. Now I will apply the limit. So it's 4/9. Take the square root. Some of you probably saw this by kind of using Mobo-Botany's ratio. You would get a 2/3. If I use the negative, would it change the answer? Nope. You would still get a 2/3. And it looks like I'm out of time. That last one I will still record, but after you guys leave, so I gotta pause. Alright, so finishing just this problem, we have my biggest power of x in the denominator is x squared, so I would have sine of 5x is x squared, but if I were to divide everything, it's really not going to do anything to this but recreate the original. So if I said this was that, and the bottom was x squared, and it was over x squared, these would cancel, and the original problem is still remaining. So ultimately, this is the answer. 5x, partition out the x squared so that it's x times x. The limit is applied, and on an infinite limit, if you remember way back when, this right here would reduce to 5 itself. Okay, so sine of ax over bx would reduce to a over b, which is 5 over 1. The x is still remaining, so 5 divided by infinity, because you're plugging it in, would yield an answer of 0. So your answer for this is not 6. Your answer for this would be 0.